My name is Lusanda Vika from OR Tambo Inland, a subject advisor for agricultural sciences. Welcome to ECDOE Broadcast Studio. Our today's lesson is a continuation of what we did in the previous lesson of animal nutrition. I will be covering this topic for your full understanding. Then another calculation that we have is a calculation on a Pearson square. Learners used to confuse a calculation for a nutritive ratio with a calculation of a Pearson square. I think what confuses the learner is that at the end, the question of calculating a Pearson square, it calculate the ratio in which feed A needs to be mixed with feed B. So the Pearson square is about balancing a ration, whereas with nutritive ratio, we're looking at the quality of a protein in a feed. As I have mentioned, we indicate the protein content in a feed with the nutritive ratio, the protein content in a feed. Whereas with Pearson square, we are balancing a ration. We are balancing a ration. So, for instance, protein-rich feed needs to be mixed with energy-rich feed so that what the animal consumes is balanced. An animal doesn't need to consume a feed with only a protein or a feed with only carbohydrate. So both of these feeds need to be balanced to get the required nutrient values by a farm animal. So when balancing a ration, we're talking of a ratio. Feed A is to feed B. Here we go. We have this activity. A farmer used maize meal and sunflower oil cake meal to prepare a ration containing 16% to prepare a ration containing 16% DP. The DP of maize meal is 14%. And the DP of sunflower oil cake meal is 45%. So here, learners, they don't confuse this one. They get it first time. That the desired one, a farmer prepares a ration of, so they know that you put it, this is our Pearson square, you put it in the middle. A farmer wants to prepare a ration containing, so they don't confuse this 16% DP they put in the middle, which is well and good. I will use abbreviations, Mfundi. So the DP of maize meal is 14%. So the first feed that you are given, you put it in the top left corner of the square. So I will use abbreviations, the maize meal with a DP of 14%. Then the DP of sunflower oil cake meal is 45%. Sunflower oil cake meal is 45%. Yeah. Then, Mfundi, I used to say, give a name to a child before the child is born. So we have to transfer the names of the feeds. Either it was said feed A, feed B, you have to transfer feed A, feed B. Now it is maize meal and sunflower oil cake meal. So we have to transfer the names before we start calculations. Sunflower oil cake meal, because this is where you start to confuse things. Then we always calculate diagonally. We minus the small number from a big number. We do not have a negative number either way. That is, we say 16 minus 14, 45 minus 16. We calculate diagonally. 16 minus 14, we always minus the small number from a big number. 16 minus 14, so it's 2 parts. 16 minus 14, 2 parts, and then 45 minus 16. Of a calculator, I'm finding 45 minus 16 is 29 parts. Yes. So the question says, to calculate the ratio. So we are doing 1.2. Use the method in question 1.1 to calculate the ratio of maize meal to sunflower oil cake meal. So the ratio, you are not done, Mfundi, until you write the ratio. The ratio is maize meal to sunflower oil cake meal, which is maize meal is 29 to sunflower oil cake meal, which is 2. So there's a mark for preparation, there's a mark for parts of the maize, there's a mark for parts of the sunflower oil cake meal, there's a mark for a ratio. So that one is 4 marks. Ne? And then number 1, we skipped number 1. Name the feed formulation mentioned used to prepare a ration that contains a DP of 16% by mixing maize meal and sunflower oil cake meal. The formulation is a Pearson square method. And then number 3, calculate the percentage of sunflower oil cake meal. Good learner, if you missed the names of the parts on the right side, you may be confused when it says calculate the sunflower oil cake meal. So the sunflower oil cake meal is 2. So when calculating, you will first add. So this is our 1.3. You will first add the 29 plus 2, which is 31. And then you get and go into the percentage of sunflower oil cake meal, which is equal to 2 divided by 31. Because we are calculating a percentage, you'll say times 100. So this is it. Now let us go to our solutions. What we get, it is 6.45% okanye 6.5%. Now looking at 1.4, a farmer mixed 15 parts. Oh, remember, Mfundi, when we get to the right side, of the Pearson square, we no more talk, Mfundi, of percentages. We are talking of the parts. If you by mistake you write percentages, you are wrong. You won't get a mark. So when you go to the right side, you talk of parts. Percentages, they cancel each other, and then on the right side you write the parts. So 1.4 now, a farmer mixed the 15 parts of feed A with 5 parts of feed B to get a ration with 16% digestible protein. Calculate in kg the quantity of feed B required in a 75 kg ration. Show all calculations. I love this show all calculations because it also appears in the instructions. So here you are required to calculate feed B, calculate the quantity of feed B. So the quantity of feed B is 5 parts to 750 kg with feed A ongu 15 parts. Here we go. 1,4. We first add the 15 plus 5, and then we get 20. And then feed B is 5 parts. So this is our 5 parts divided by 20 times 750. Then in kgs, so it appears there. So you get your full marks. Then the energy values of a feed. What is an energy value? Energy. Greatest portion of feed is used to produce energy. We know that when we as human beings, when we eat food, we get energy. One of the functions of food in our standard 2, then we used to say food gives us heat and energy. Even now, food gives heat and energy. So when we talk of the energy values of a feed, we say most of the feed that is produced, most of a feed that is eaten by an animal is used to produce energy. So the energy value of a feed is expressed in kilojoules. Some used to say joules, whatever. So let us say kilojoules. So the total energy released by an animal when a feed is burnt to its oxidative product. Like for instance, now I've just taken my meal. So the total energy that I have is called a gross energy. A gross energy is the total energy that is produced when a feed is burnt to its oxidative product. What are these oxidative products, Mfundi? Oxidative products is gas, the carbon dioxide, the methane. Then we talk of the gross energy, which is the total. So this total energy is used to produce heat. This total energy is producing heat. Body of an animal now gets heat and energy after getting this feed. So when an animal starts to to defecate, that is, it excretes manure, we talk of digestible energy. Digestible energy is the amount of energy absorbed after feed has been consumed. The measure of the amount of energy absorbed after consuming a feed. Now, when we do a calculation of a digestible energy, we say digestible energy is equal to gross energy. Digestible energy is equal to gross energy minus energy lost in manure. Energy lost in manure. Fundi, when calculating these energy values of a feed, you will always be given figures or values. So when we say digestible energy is calculated as gross energy minus energy lost in manure, this is the formula of it. You will listen to the question. And then when an animal loses urine, gases, or methane, and manure, we talk of metabolic energy. Now you are required to calculate metabolic energy. You will say metabolic energy is equal to gross energy minus, in brackets, energy lost in manure plus energy lost in urine and gases. You will look at the values if you are given a value of gases. But when you calculate metabolic energy, you will start from saying gross energy, that is the total energy, minus these energies that are lost when an animal defecates, when an animal urinates, or when an animal excretes the gases. Then lastly, we have the net energy. Also, net energy, that is the formula. The net energy is equal to gross energy minus, in brackets, energy lost through manure, through urine and gases, through the body heat. You combine all those energies, you minus them from the gross energy, and then you will get the value in kilojoules. As we said, the energy value is expressed in joules. So you will listen to the question, you will be given these values, but what you must know, you minus all these energies from that total energy that has been produced when an animal digests feed into its oxidative products. Here is an activity. I will just read the activity and I will only read the answers. The schematic representation below indicates the energy flow of maize meal that was fed to a pregnant farm animal. Now, again, good learner, know that for every calculation, there is an implication. You have to interpret the calculation, meaning in your calculation, look at the value. It means more of the energy has been lost. So what is left for an animal to work, to produce, or to do work? What is the amount of the energy that has been left for an animal to do work? Like for instance, it has lost energy through manure, it has lost energy through gases and urine, it has lost energy through body heat. What is the energy now that is left for an animal to do its work? Let's say its work is to produce, reproduce, or grow. Then 1.1, define the energy represented by A. So know these energies sequentially. So we mentioned the gross energy, the digestible energy, the metabolic energy, and the net energy. So they will always be sequential as that. And when we're calculating the three, the digestible energy, the metabolic energy, the net energy, we will start by saying is equal to gross energy minus loo nto uyibuzwayo. Minus what is being asked. Gross energy minus what is you are required to respond to. So define the energy represented by A. After gross energy, we have digestible energy. Why? We are looking at the loss, at the energy loss, which is fecal. So obviously, digestible energy is the energy lost through feces. So obviously here we have a digestible energy. Energy losses through gases and energy. B, through gases, it is metabolic energy. Energy lost through heat production, so it is net energy. So you will listen to what is being asked or what is being required. So write down, a good learner, the response for that. 1.2, label B, gases and dash energy. You know, we said gases and urine. 1.3, state one function of energy represented by E, that is the net energy. 1.4, calculate the value of the energy represented by C and show all your calculations. Energy represented by C. Energy represented by A is digestible energy. Energy represented by C is metabolic energy. Now let us go to the answers. The definition of energy: A, digestible energy is the gross energy value minus energy lost in feces. Or digestible energy is a measure of the amount of energy absorbed after consuming a feed. So the label there, which has got a space, we said urine and gases. 1.3, one function of E, it is for maintenance, production. What is left for an animal to do its work? I said it may be for maintenance, for reproduction, for growth, for all the activities that an animal needs to do. After all these energies has been lost from that total energy that has been produced after the feed has been burnt to its oxidative product. Then that is 3. Then for calculation of C, we were calculating the metabolic energy, that is the formula. It is about the gross energy. I said we start from gross energy and we are required to calculate the metabolic energy. So it's metabolic energy minus gross energy into brackets. So either way, you can calculate this way, you can calculate this way. Gross energy minus 9.8, that is for urine and gases, and for manure, 9.8 for manure, and 4 for urine and gases. Either way, you can calculate. Here below, the calculation says plus. You plus these two energy losses, but it gives you the same answer. So we have seen the digestibility coefficient from the previous lesson. Now we continued with other calculations, the nutritive ratio, the Pearson square, the energy values of a feed. So we will continue from here to finish our calculations and continue with the lesson of animal nutrition. We have come to an end of our lesson. You can leave your questions on the comments. Don't forget to leave the name of your school so we give shout outs. Please share, recommend, and subscribe to our YouTube channel. Thank you for watching. See you on our next lesson on this same topic of animal nutrition. Thank you.